The next thing would be to actually look at the polar maps. So what you're seeing as part of the scores is part of our image decision support. That's part of the AI tools that Michael was talking about earlier. So there's a lot of probability analysis that goes into the original numbers that don't have any decorations on them. So a score of 0 means that from the probability analysis, the computer decided that there wasn't a problem in that particular segment. That's why it scored it as 0. Wherever you see a circle, that means that the artificial intelligence system looked at the score that came out of that analysis and then changed it. So here in the inferior wall, you can see that it was originally a score of 1 that was changed to a score of 0. You can see that here also in the inferior wall. More interesting is here in the lateral wall, you can see that it was originally a 4 and changed to a 2. And so the question hopefully is, well, how did the system know to change the scores? And the way the system knew to change the scores is because it's looking at both the non-AC images as well as the AC images. So you can see in this segment, there's quite a bit more activity than there is from non-AC, and enough that the system brought that score from a 4 to a 2, very much like a physician does. A physician doesn't mentally score the non-AC images separate from the AC images. They look at all of the images together and then combine the scores and come up with a gestalt of what's going on for this particular patient. And that's exactly what the artificial intelligence system is doing behind the scenes. And so the scores that you see here, we call SMART scores. And those scores are a result of the AI system that's built into the program. But not only the scores that you see here, but I brought up the report a little earlier. It has also read the study and come up with a paragraph. So it saw this lateral wall defect, some score of 6, mostly reversible. And based on ASNC guideline reporting standards, 3 segments qualifies as a medium-sized defect. A score of 6 qualifies as a moderately severe defect. And then because it's in the septal wall, because it's in the lateral wall, it's consistent with ischemia in the left circumflex territory. And so again, all of that was brought out because of the artificial intelligence system that was built into it. And then it's put into a paragraph that's here at the bottom of this page, but also on the final report page. It comes up with the nuclear perfusion findings. You can put some images, and then it tells you what the ejection fraction is, and then it would tell you the impression. As far as the reporting is concerned, there's a lot more to the reporting system, and I'm happy to answer more questions about that if you want to. But there's a lot of, it's kind of a point and click interface, where as you're reading the study, you can set up what the general, why was the patient referred for imaging, what was the protocol that was used. This information can be entered as the treadmill protocol or the pharmacologic stress was being done. What was the baseline EKG findings? What were the stress EKG findings? We've talked about the fact that it has auto done the perfusion. If you don't agree with it, that can be changed. Was there wall motion, wall thickening? And then what was the conclusion based on that? And then all to the final report. And the nice thing about the report is if you didn't enter something that is required by the report, it's going to put a little red required just to encourage you to go back and fill that part in.